The broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone. So we are just going to start now. We have our panelist, Stefan, that will talk to you for the next hour or so. We are monitoring the chat window, so if you have any question at any time, please raise your hand or type a question in the chat, and we will be responding. We will point that to Stefan and he can respond. And then we are going to start recording this webinar, and we will be posting the recording in Canvas for you to consume also at a later time, and other people to do the same. Yeah, so I think we can get started, Stephen, if you're ready.
Yes, I am.
Perfect. So I'll go on mute and let me just start recordings. Recording is starting now. You can go.
Okay, I take it from there. Thank you, Antonella, and welcome everyone. And I maybe like to say good morning, good afternoon, and good evening wherever you are. It's a real pleasure to be your host today for this AWS Restart webinar about DynamoDB building NoSQL data-driven application. My name is Stefan Roux, and I'm a solutions architect at AWS in the Enterprise Greenfield team, which means, because you might not be familiar with which means I'm working with new customers, new to AWS. And as you probably guessed it already, I'm French, and I'm based in the south of France right now. Okay, let me switch to the next slide if I mentioned that. Okay, sorry for that. Before we can start talking about DynamoDB, which is, of course, the main topic for today, I'd like to spend maybe a few minutes to talk about my own experience and how I did end up there. And the picture on the slide is a hint, but a tricky one. And I could give you maybe a couple of seconds to guess what is my educational background. But believe me, this is far from IT, even though a bit technical, of course. So breaking the suspense, I graduated both in applied physics and quantum mechanics. And to be quite honest, I've never used it really or applied it directly to any job position I got. And how I got started in IT would probably resonate with you because I believe that that's something that could make sense. Basically, I was looking for a job after I graduated, and I was a bit in a rush. And I found this job offer about training computer science for beginners. So that was not something super technical. And again, that was not my educational background. And I was somewhat familiar because computers were everywhere at my university, and I applied for the job, and surprisingly enough, I got it. And this is maybe fate or whatever, but this is where I received the best piece of advice in my career, and I want to share it with you. I'm still using it today at AWS. And I got it from my boss at that time, and it's pretty simple, nothing really crazy, but it just told me to be curious, never stay in your comfort zone, always challenge yourself for something new. And I guess that this is even more a good advice today, given the pace of change in technology, something we will probably talk about during this presentation. So as a consequence, I learned a lot about networks, operating systems, and I found a new position as a consultant and so on, until I joined AWS a year and a half ago. And you know what the funny part of the story is? I first joined AWS as a trainer. So the circle is complete. So that's for my personal experience. And besides AWS, of course, I'm really curious about everything. I'm a part-time musician, and I'm doing a lot of DIY and that kind of stuff. So nothing really related to IT. So again, I hope that maybe it will resonate to you. You can always, find your way in the world. All right, let's stop this and let's switch to the real content for today, the real topic, which is DynamoDB. And before we can talk about DynamoDB, I would like to talk about how our organization can take advantage of data. And in order to do that, we could first talk about 3 major trends that impact the way you think about data. So the first one is the fact that there is a real explosion of data being generated. So obviously you're all using a smartphone today, you're all using application, and it's in itself, if you consider that, if you're comparing that to 10 years ago or 20 years ago, it's a huge change. And as you can imagine, you're generating a lot of data with your mobile app and all of these devices. And today, the growth is coming from data generated by all kinds of network connected smart devices that drive variety and volume of data. So smart devices, that's not only mobile phones, that's also connected cars, that's smart homes, that's wearable technologies, that's home appliances, security systems, industrial equipment, machinery, electronics. And applications also generate real-time data, such as purchase data from e-commerce sites, user behavior from mobile apps, and tweet posts from social media. By our estimates, we consider that data grows 10 times every 5 years. And to take advantage of all of this data, you need to be able to use the right tool that will be able to handle this volume of data. And that's something super important. And of course, that's the basis of this presentation. The second trend we're seeing is the fact that organizations are moving from development of monolithic applications to microservices architecture. Let's spend a few seconds to just explain that in details. Again, 10 years, 20 years ago, organization was used to develop applications, all-in-one applications. It means that the same application was embedding not only the presentation tier, the presentation layer of the application, but also the application logic, and also the database or other, storage tier. That was not really flexible because it means that when you needed to make some improvement or to add new features or check the behavior of the application, that was just a huge and a big mess. And moving to microservices lets organization break down a complex problem, a complex application into independent units, so developers can operate in small groups with less coordination and therefore respond more quickly and go faster. So the fact that developers can break down their application into smaller pieces, it means that they are not beholden to using a single database for every workload. And that's very important, again, because 10 years, 20 years ago, we were using mostly relational database. And you will see in the next slides that now we have way more capabilities and services around database services than it was the case in the past. The third trend that we're seeing is the fact that not only organizations are moving to new technical way to develop applications, but also to new kind of organization. And as we innovate quickly and the velocity of IT changes, businesses are transforming, we need to adapt also the organization. And that's the whole purpose of the DevOps model. So this model uses basically automated development tools to enable continuous development, deployment, and improvement of software. So it goes, hand in hand with the microservices design pattern. But that's something we really see nowadays. It's a huge change. That's the 3 trends that we are seeing nowadays. And as you can imagine, it will be a perfect driver for DynamoDB use cases. So basically, most of your organization today are facing or faced very specific challenges. The first one is scalability. And scalability, it's important to businesses because they ultimately leverage the cloud to reach more and more customers to grow their businesses. And customers need the flexibility to scale their databases up and down quickly, and without having to deal with the complexity of managing hardware in the background. The second challenge is probably developer efficiency. And developer efficiency, that's super important for customers because when developers are more productive, they can ship products which open new revenue streams at a faster pace. So we can look at AWS. Our pace of innovation is at cornerstone metric which earns trust with customers and help us deliver results by increasing customer adoption, for sure. The third challenge is about performance. So you understand that in today's digital age, user experience is paramount. And when you're using your mobile device, if you have to wait more than a few seconds to get the result of your action on your favorite social app, you will say something is not working. So that's definitely a key. Nowadays, we definitely need to have milliseconds, microseconds latency for applications, and that's very important for most of the businesses. And last but not least, the last challenge we have on this slide, it's of course the costs. Businesses are always seeking to improve their profitability, and for customers running legacy database environments on premises or self-managed in the cloud, provisioning, managing, and scaling database solutions is tedious, time-consuming, and ultimately it drives up the total cost of ownership by using people resources on tasks that we can automate instead of investing that time to innovate. So now that we developed a little bit on the main challenges that organizations are facing today, it's important to mention that we have three ways customers consume AWS database services nowadays. And that's something important because I use that in the next slides to explain how to position DynamoDB in AWS database services ecosystem. So first of all, our customers want to take advantage of the huge portfolio of database services that we have at AWS by using the best solution for their use case. So for that, we have many different purpose-built database services at AWS. We're going to talk about a single one today, which is DynamoDB, but we have plenty of database services that could provide many interesting features for specific use cases. And for modern application, for microservices oriented solution, DynamoDB and NoSQL database services are certainly a key. That's also a way for customers to move to managed services. You will see that one of the main benefits of DynamoDB as well is to be a fully managed service. So it means that we will take care of all the undifferentiated heavy lifting. We will take care of all the infrastructure for you, and you will be able to focus on what you want to achieve through your solution. And of course, that could be a way also for our customers to move from legacy databases, migrate old commercial databases to open source engines, for instance, Oracle to DynamoDB. And that's something I will, of course, talk about when I will talk about the Amazon example. Because we moved from Oracle database to DynamoDB for most of our application, and that's something very important for, again, innovation, agility, flexibility in terms of services. All right, so what's DynamoDB? DynamoDB, in a nutshell, is a fully managed NoSQL database service running in the AWS cloud. But wait a minute, what is a NoSQL database first? Because that might sound, something maybe a bit curious. So allow me to move forward to the next slide, and I will go back in a few seconds. Sometimes it's easier to understand what is a NoSQL database when you compare it to the well-known relational database. And even though you might not be an expert in relational database services, most of the time it's easy to understand because it's something really familiar. If you already used an Excel sheet, you know exactly what is a relational database, at least in the structure we will have in this kind of database. So basically, a SQL database stores data in rows and columns. Rows will contain all the information about one entry, and columns are the attributes that separate the data points. We have some specific constraints with relational database services and relational database structure. First of all, a SQL database schema is fixed. Columns must be locked before data entry. So of course, you can change the schema if the database is altered entirely and taken offline. But it's really something not super flexible. Data in SQL databases is carried using SQL language, structured query language, which can allow for complex queries. You can do join, grouping, ordering results. And last but not least, SQL databases scale vertically by increasing hardware power. You cannot scale horizontally with the relational database because most of the relational database services works on a single master model. So it means that only one server can be the master for the data. Of course, you will find a lot of improved services around relational database services with multi-master model, but here we're talking about the common definition for relational database services, and it will help when it comes to the comparison with NoSQL or key value database services. So on the other hand, NoSQL databases store data using one of many storage models, including key value pairs, documents, and graphs, for instance. NoSQL schemas are not fixed, they are dynamic. So it means that information can be added rapidly. Each row doesn't have to contain data for each column, and it could be completely different in terms of structure. So that's super flexible. It means that you can store in a very efficient way different kind of information, data, without having to think about the structure of the data. Data in NoSQL databases is queried by focusing on collections of documents. So that's a complete change of paradigm. NoSQL databases scale horizontally by increasing servers. And that's very important because you will see that it allows this kind of service to provide a level of performance that is just impossible to reach with traditional relational database services. So for all of these reasons, key value database or NoSQL database are commonly used for internet scale applications, real-time bidding, shopping carts, customer preferences. We'll talk about different use cases we have for NoSQL DBs and specifically DynamoDB in the upcoming slides. So if I jump back to what is DynamoDB? So it's a fully managed NoSQL database service running in the AWS cloud. So okay, now you're familiar with NoSQL database, maybe a little bit more than before. Let's focus now on fully managed. What does it mean that it's fully managed? It means that, as you can imagine, the complexity of running a massively scalable distributed NoSQL database could be tedious. And here, it's managed by the service itself, allowing software developers or operators to focus on building applications rather than managing infrastructure. NoSQL databases are designed for scale, we talk about that, but their architectures are sophisticated, and there can be a significant operational overhead in running a large NoSQL cluster. So instead of having to become experts in advanced distributed computing concepts, the developer need only to learn DynamoDB's straightforward API using the software development kit for the programming language of his choice. And in addition to being easy to use, DynamoDB is also cost-effective. Remember, that was one of the challenges we mentioned. Why is it cost-effective? Because with DynamoDB, you pay for the storage you're consuming and the I/O throughput you have provisioned. So it is designed to scale elastically while maintaining high performance. So what does it mean? It means that when the storage and throughput requirements on the application are low, only a small amount of capacity needs to be provisioned in the DynamoDB service. And as such, you will pay only for that capacity. So you will pay less. And as the number of users of an application grows and the required I/O throughput increases, additional capacity can be provisioned on the fly. You don't have to wait for hours, days, months. No, it can be done on the fly. And this enables an application to seamlessly grow to support millions of users, making thousands of concurrent requests to the database every second. And last but not least, something super important, especially these days, DynamoDB is secure with support for end-to-end encryption and fine-grained access control. More on that in the upcoming slides. Okay, we saw this one already. So let's talk about, just for a minute, about internet scale apps. So basically, we saw that applications in the internet era are really different. They have different characteristics compared to traditional applications. Why is that? Because with internet applications, users can very easily be in the millions. Data volumes can reach petabyte and exabyte levels in short order. Performance is often measured in milliseconds and microseconds. On average, the app serves millions of requests per second, and on big days, think about Amazon Prime Day, Cyber Monday, could process tens of millions of requests per second. And this application variance demands that systems can scale up, out, and in to maintain the right cost profile. Because again, what we want to avoid is the high water mark, having to size a system based on the highest usage. I have one Cyber Monday per year. I have maybe one Prime Day per year, but I don't want my overall infrastructure to be sized based on that single day of the year. So now that we understand what are the key logical use cases for DynamoDB, let's talk about use cases by industry. Where will you see DynamoDB? Where is it really a good fit? And we have good examples here on this slide. Specifically, let's start with the one I already described, retail. So when it comes to dealing with shopping carts, customer profiles, you need things to be super fast. And of course, that's something really common today, but maybe you remember, 10 years, 20 years ago when you were doing some, internet shopping. That was not always the case. Sometimes that was big, lagging. Nowadays, thanks to NoSQL databases, you have really excellent performances on that kind of use cases. Another one I want to present here, and probably you didn't think about it in the first place, it's gaming. if you think about, massively multiplayer online game, like, I don't know, maybe League of Legends, for instance, or Fortnite. Even if you never played these games, in a nutshell, it's just, a lot of users on the same map, on the same environment, virtual environment, sharing objects, sharing interactions. And you have to make sure that you can update all the artifacts, the metadata for all of these users real time. It has to be real time, because if you have to wait just 1 second to see something, when you're interacting with the game, it will be totally useless. The experience will be horrible. So basically, this is an excellent use case for DynamoDB and NoSQL databases. And of course, we have much more than that. We have advertisement technology that's everything related to the fact that when you're browsing a website, when you're using your free mobile app, you will get targeted advertisements. And it works because in nearly real time, you have something that is able to collect information coming from all of your previous history, and then pushing you the right information for you based on your context. That works on DynamoDB NoSQL databases as well. So that's just a couple of use cases. Of course, everything on these slides is relevant, and that's super interesting to think about it. All right, so let's just dive a little bit deeper into the performance topic. So as mentioned previously, DynamoDB has experienced some extreme scale in real-world scenario. I mentioned Prime Day, Cyber Monday, other events like these ones. And though many AWS customers will not require this level of scale, for sure, it is nice to know that DynamoDB is regularly tested, battle-hardened, well beyond the requirements of your business. That's important. And I mentioned advertisement technology applications. They typically require extremely low latency. Again, this is well suited for DynamoDB's low single-digit millisecond read and write performance. So that's definitely, again, something that is super important nowadays for these applications. And I mentioned it, very popular applications. You can also use, DynamoDB database services in monitoring solutions, for instance. Monitoring solutions typically ingest hundreds of thousands of data points per minute. And DynamoDB's schema-less data model, high input-output performance and support for native JSON data type is a great fit for these types of applications. So that's something really important to understand for DynamoDB use cases here. And in the same way, DynamoDB provides not only high throughput, but also consistent and predictable responsiveness. That's important. Whether you have thousands of users or millions of users or thousands of millions of users, you want to make sure that you will have consistent and predictable responsiveness. It means low latency, whatever the usage of your database is. So that's really important, specifically in gaming, ad tech industries. So that's part, again, of the key characteristics of DynamoDB. Another important feature that we have with DynamoDB, which helps scaling, is the global table feature. So in a nutshell, global tables, it's built on DynamoDB's global footprint, which means that DynamoDB is deployed across the 25 AWS regions right now. And it provides you with a fully managed multi-region and multi-master database that provides fast, local, read and write performance for massively scaled global applications. So if you think about one of the use cases I mentioned previously, massively online gaming. In that case, you have players all over the world. You have to make sure that your backend will be able to handle that scenario, making sure that wherever your users are, you will be able to consolidate information in nearly real time. And in that case, global tables will replicate your DynamoDB tables automatically across your choice of AWS regions. That could be, why not, the 25 regions, but maybe only the regions where you have users, players. And the whole idea behind it is the fact that, again, it's fully managed. So global tables will eliminate the difficult work of replicating data between regions and resolving update conflicts, enabling you to focus on your application's business logic. And of course, on top of that, the cherry on the cake, global tables will enable your applications to stay highly available, even in the unlikely event of isolation or degradation of an entire region. So that's really interesting. Another interesting feature that we have is DynamoDB Accelerator. So what is DynamoDB Accelerator? It's a fully managed, highly available in-memory cache for DynamoDB. So what's the purpose of in-memory cache? When you hear in-memory, immediately it sounds like something that will be faster, because memory, it's always faster than drives. And that's the case here. So when you need even more performance, remember that DynamoDB in itself, it's already impressive in terms of performance. But if you need even more, you can use DynamoDB Accelerator, DAX. And DAX will deliver up to 10 times performance improvement from milliseconds to microseconds, even at millions of requests per second. And of course, as usual, DAX does all the heavy lifting required to add in-memory acceleration to your DynamoDB tables without requiring developers to manage all the actions related to cache, for instance, cache invalidation, data population, or cluster management. So now it means that you can focus on building great applications for your customers without worrying about performance at scale. You do not need to modify application logic because DAX is compatible with existing DynamoDB API calls. So again, it's a huge game changer. All right. So really important topic that we already mentioned a few slides ago is the fact that thanks to managed services and specifically DynamoDB, you will be able to get back valuable time for your business because you don't have servers to manage. And we mentioned that DynamoDB does AWS does the heavy lifting for you, but it's across a lot of different topics. It will, manage for you automatically the security aspects. So everything related to operating system patching, database patching, access control, audit, encryption, compliance. It will take care of durability, just by making sure that you will be able to sustain server, rack, or data center outages. It will replicate data quickly upon hardware failure. It will manage automatically for you backup and restore. It will take care of high availability configuration, monitoring, cross-region replication. And of course, in terms of performance, automatically it will do performance tuning with allowing for you to, maybe if you're a little bit familiar with traditional relational database services, you know that you have to fine-tune the queries just to make sure that you're using in the most optimized way your database. A a lot of these tasks are handled automatically by DynamoDB, even though, of course, you still have to optimize your application. And scalability with the host provisioning and host repair and requirements, everything is handled automatically. That's very important to mention that. All right, my slide's stuck. Okay. Something really important to emphasize on is the fact that not only you will be able to focus on what you're trying to achieve, but the DynamoDB provides also a provision capacity mode with auto-scaling, which will maintain performance for you without having to do anything. So that's very important. And what you see on this slide, it's a CloudWatch. CloudWatch is the monitoring service that we have at AWS. You might be familiar with CloudWatch. Now, it's a CloudWatch view of provision capacity and usage. In most database services, relational or even NoSQL, when it's not fully managed, you provision way high. You know, that's the high watermark I was talking about previously, hoping that you don't approach your capacity line. So basically, it means that if the capacity is set too low, you will have availability impact. And if the capacity is set too high, you will have financial waste. So basically, you can't win. But with DynamoDB, auto-scaling, set it and forget it. And DynamoDB will take care of, adjusting the capacity automatically. So that's, again, a huge game changer. Okay. DynamoDB provides different way to consume the service. DynamoDB On Demand is a flexible new billing option for DynamoDB capable of serving thousands of requests per second without capacity planning. So it means that basically, like most of the services we have at AWS, you're consuming only on demand for what you need at the moment. So it offers a simple pay-per-use, pay-per-request pricing for read and write requests, so that you only pay for what you really use. And it makes it easy to balance costs and performance. Again, just compare that to traditional IT infrastructure on premises. You will have to provision hardware, you will have to provision software, you will have to pay for all of this even before using the service. With DynamoDB, you don't need that. You will consume the service as soon as you need it. When you don't need it, you just, not using it, you're not paying for it. And for tables, using the on-demand mode, DynamoDB instantly accommodates customers' workload as they ramp up or down to any previously observed traffic level. If the level of traffic hits a new peak, DynamoDB adapts rapidly to accommodate the workload. So again, that's definitely a win-win situation. So let's recap the benefits of a fully managed NoSQL database. First of all, you will reduce risk because you will never run out of capacity. DynamoDB will be able to automatically adapt to your workload. You will be able to protect your data with managed backup and restore, point-in-time recovery, and global tables. So it means that it's very unlikely that your business should face an outage, at least as long as you're designing your application accordingly. With DynamoDB, you will be able to reduce costs because, first of all, you will reduce database operational support. It's a managed service. You're focusing on the business outcome. You don't have to deal with the infrastructure hassle. And remember, infrastructure, it's super expensive to scale if you compare with traditional on-prem environment. And you not only have the hardware cost, but you also have the software cost most of the time. And here, it's nothing to consider. You're only paying for what you use. And of course, DynamoDB will allow you to move faster. Operations will never slow you down again because, again, you don't have any infrastructure to deal with. You can immediately provision massive amounts of capacity without touching a server or without having to buy new servers. And you will stop wasting time on capacity forecasts because obviously you don't have to do that anymore because DynamoDB will be able to adjust to your specific workload. So that's really key aspects of DynamoDB that makes it a great service to build database-driven internet application and modern applications nowadays. All right, let's switch for a few slides to a specific topic around security, because security, you know that it's something very important. We tend to say that it's job zero. It's the most important job at AWS. And obviously, DynamoDB will embed a lot of security features. Let's talk about a few of them, because obviously we could take, hours, talking about security features in DynamoDB. First of all, it's important to emphasize on the fact that we have, of course, access controls and encryption at rest available natively with DynamoDB. So DynamoDB is fully integrated with AWS IAM, which stands for Identity and Access Management. You should be familiar with IAM as well. So basically, it means that you will be able to leverage the roles that you can configure in IAM to make sure that your users will only get access to the right service and to the right piece of information. So it's very granular, and you can definitely use that. You will be able, of course, to secure the network aspects of DynamoDB. We have features really interesting that will allow you to access DynamoDB through secure Amazon VPC endpoints. So it means that if you don't want your DynamoDB service available through a public endpoint, you will be able to make DynamoDB only available through a private endpoint. So it means that you will be able to make sure that your application that you also developed in AWS will access your DynamoDB table directly from the VPC without having to go outside the internet. But of course, it's interesting to have public endpoints if, for instance, you have applications on premises that need to access your DynamoDB tables. So in that kind of hybrid setup, that's really interesting to still have public endpoints. And of course, I mentioned it already, all tables are encrypted in transit and at rest by default. So that's something super important as well, and something customers are really, focused on based on the fact that security is a major concern for all of them. And security, it's not only making sure that your data is secure and making sure that only the right users will access your DynamoDB tables. It's also the operational aspects of security and making sure that you can audit all the actions on your DynamoDB tables, and you can make sure that everything related to any aspects of DynamoDB will be captured accordingly. And for that, we have a specific service in AWS CloudTrail. And AWS CloudTrail, you're probably familiar with that service again. It's a service that enables governance, compliance, operational auditing, and risk auditing of your AWS account. And with CloudTrail, you will be able to log, continuously monitor and retain account activity related to actions across your AWS infrastructure. CloudTrail provides event history of your AWS account activity, including actions taken through the AWS Management Console, AWS SDKs, software development kits, command line tools, the CLI, and other AWS services. So once enabled, you get a CloudTrail with all management events automatically and at no charge. And then you also have several different data plane event sources that you can opt in, depending on your particular application and compliance needs. And of course, DynamoDB is fully integrated with CloudTrail, so it means that whatever you're doing on CloudTrail, you will get the information in the service. And you even have history that is another source of observability data that we provide, and it simplifies security analysis, resource change tracking, and troubleshooting. So that's definitely something that goes well beyond the DynamoDB, because auditing it's definitely a key aspect of managing your AWS environment right now. But it's important to mention that DynamoDB, of course, is fully integrated into this service. All right, let's finish with probably the best use case that we can have for DynamoDB. And this is the use case at Amazon. Yes, we are seeing customers such as Amazon.com migrate off even the old gold standard of our RDBMS, and I'm talking about Oracle in that case. And we discussed earlier, even if Oracle can scale for you, it's very costly and it doesn't scale in the same way, and it isn't conducive for DevOps model. So basically, Amazon moves most of the legacy databases running on Oracle to purpose-built database services. That's not only DynamoDB, but that's DynamoDB, and specifically for everything related to the retail activity, DynamoDB is again the perfect choice. It allows to improve customer experience with workflow processing delays dropped from 1 second to 100 milliseconds, to reduce costs, scaling and maintenance effort dropped 10 times, and to reduce complexity and risk. And thanks to that, Amazon.com retired more than 300 Oracle hosts, which is really impressive, of course. All right, so this is the end of the presentation right now. So maybe you have some questions. Let me see in the interface if you have something.
Yeah, I think Tim was monitoring the chat. So Tim, do you have any questions from the chat? It's been quiet, I think. So looks like we are probably good, Stefan.
All right, so it means probably that it was crystal clear.
So they have also an alias that they can reach out to, both as a follow-up of this and as well as to ask technical questions. And they have both of them available to them in their Canvas environment. So if they reach out to us with any question on this, we'll make sure that you can respond to them, and we can continue the journey out of this webinar. So thank you so much. Thank you everybody for your time, and feel free to reach out through, again, the Canvas or the aliases. Thank you. Thanks, Stefan. Thank you. Bye.